For 9.2, the substitution method. So we're doing systems of equations. Systems of equations are when you have two variables and you have two equations representing those variables in different situations, or different relations. So when you have it, we just finished 9.1. In 9.1, we used the graphing method, which was great. And it was familiar, especially because we use slope-intercept or we use standard form to graph all the solutions. That's nice because you can see all the solutions for each of the equations, and then you look and see where do they intersect. That intersection represents a solution for both of the equations. And as long as it intersected on a grid line, it was very easy to see the solutions. But as we saw, sometimes it doesn't. Or maybe I'm graphing and that I have to graph an x-intercept at a half or 5 halves or 7/4 or something like that. And it just doesn't come out in a very accurate way. So the next method we're going to use is called the substitution method. Substitution is we take one of these equations and we isolate it for a variable. And the problem why we can't solve this in the first place is because we have two variables. If we solve for x, we get it in terms of y. If we solve for y, we get it in terms of x. You can never isolate a variable and get a constant. And so what we do is we isolate one of the variables and substitute it into the other one. That's one of the major important things is if you're going to isolate a variable y in this equation, we have to plug it in for the other equation. We can't plug it back in. I call it cannibalizing. You can't cannibalize. You can't take this and then plug it back in there. So what you do is you isolate for y, and then in the other equation where we see y, we're going to substitute this value. And the beauty of this new equation is, notice we only have x, one variable here, so we can now simplify, isolate, and we can find out the value, and then we can plug it back into either equation. Typically, we plug it back into the one that has y equals, so my x value, and then it'll just nicely simplify to what my y is. And then I have a solution. I have 7, 2 would be my intersection or the solution to both of the equations. It's the solution that they both share. Good? All right, let's try it out. First example, and this is nice, they start off with, the equation already isolated, so we're going to take this and we're going to take this value, and wherever we see y, we are going to substitute. So wherever we see y, we're going to substitute this 3x. So this equation now becomes x plus 3x equals 12. Let's simplify the left side. 4x equals 12. Divide by 4, x equals 3. And now we can take either one. This one's better because we're looking for the y. We have our x value, we want our y, and this is already set up for telling me what y is going to equal. So y equals 9. Sometimes you want to put it as a coordinate, sometimes you don't. I don't mind that. I think that that's a good way of doing it. Again, this is really nice. We are going to take this value, y is equal to 2x, so we're going to plug that in for y. Notice this says the opposite of y, so when we rewrite this equation, we have 5x minus the y value, which is 2x equals 12. 3x equals 12, divide by 3, y equals 4, x equals 4, and then we take this, let's go, y equals, my x value is 4, so y equals 8, and my coordinate is 4, 8. We have this, we're going to substitute it Do I need to highlight that each time? We're going to substitute it in for A, not B, Mr. Mac. We're going to substitute it in for A. We'll put that 4B in for the A value, so we get 4B minus B equals 9. 3B equals 9. Divide by 3. Divide by 3. B equals 3. A equals 4 times the B value, which is 3. So A equals 12. When we write coordinates, we write them in alphabetical. So we do our A value, then our B value. Sorry. We're going to take that N value and we're going to plug it in for M. This is our first one where we have 3 M values. So we have 3 times my M value, which is 5N, minus 2N equals 26. So we see where we had 2 variables, we now have 1. We multiply before we add or subtract. That's going to be 13N equals 26. Divide by 13. Divide by 13. N equals 2. Take that. M equals 5 times N. M equals 10. M, N in alphabetical order. So a little bit larger now. It's isolated, and where I see y, I'm going to put everything that y equals. So 2x plus my y value, which is x minus 1. We don't need a quantity. You could write a quantity if you want. You just need to write one more line. We would distribute that positive, and we know that distributing a positive doesn't change any of the values inside the parentheses. You get 3x minus 1 equals 5. Add 1. 3x equals 6. Divide by 3. X equals 2. Take that. Write y equals, my x value is 2 minus 1. Y equals 1. So, whoa. I put a solution set. We are not going to do a solution set. We're going to do a coordinate 2, 1. So we have x plus my y value. I'm going to continue to write that. I'll distribute x plus 4x minus 1 equals 4. 5x minus 1 equals 4. Add 1, add 1. 5x equals 5. Divide by 5. X equals 1. Y equals 4 times my x value minus 1. Y equals 4 minus 1. Y equals 3. So we get the coordinate 3, 1. Now, neither is isolated. So I can isolate for x, I can isolate for y in the first equation, I can isolate for x or y in the second equation. Which one's going to take the least amount of work? Well, I think that I'm going to take this equation and I'm going to isolate for, I'm going to take this, I can isolate for x or y. I'm going to look here. Do I want to solve for y and plug it in for the negative? I think I'm going to isolate for x. So we'll do that. We will set it equal to x. And then in this equation, where I see x, I'm going to substitute this value because x equals that in terms of y. So 2 times, instead of writing x, I'm going to write negative y plus 3 minus y equals 6. Negative 2y plus 6 minus y equals 6. I just distributed both of those. I'm going to simplify before I move. 3y plus 6 equals 6 minus 6 minus 6. Negative 3y equals 0. Divide by negative 3. Divide by negative 3. Y equals 0. And now this is already set up for finding y, or for x. So I have x equals negative 0 plus 3, x equals 3. So my coordinate is 3, 0. And I get the same answer no matter which way I solve for either. I could have solved for y here, could have solved for y here, I could have solved for x here and plugged it back in. If I'm going to isolate this equation, I plug it back into the other. That is the number one thing that you need to be aware of. So which equation? I'm going to isolate this one. I'm going to add y over. I get x equals y plus 2. I'm going to take the other equation, and I'm going to plug it in for x. I get y plus 2 minus 2y equals negative 1. Let's simplify. 2 minus y equals negative 1. Minus 2, minus 2. I get negative y equals negative 3. I'm not isolated. I got to get rid of that negative. So y equals 3. And now I'll go back to this equation. Y equals 3 plus 2. X equals 5. So my coordinate is 5, 3. I'm going to isolate for this one. Oh, no, I'm not. Nope, 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 nope. I'm going to isolate for this one. I'm going to solve for y, though. So I have 3x. Oh, yeah, I'm going to go back. Sorry. I'm sorry. It doesn't matter, but I'm being a bit of a... I'm questioning myself. I was thinking I was going to move the y over. I'm going to move the x over. And I get y equals negative 4x minus 5. So I solve for this one, so I got to plug it back in to this one. I have to be very careful. Don't make that mistake. So if I have 3x minus, now this actually made a bit of a, but this is good that we showed this, minus the y value. So I need parentheses because I need to do the opposite of my y. This says the opposite of y. So I have to change all of the values here. Equals negative 9. Let's move this over a little bit. Create some more space. 3x plus 4x plus 5 equals negative 9. That's 7x plus 5 equals negative 9 minus 5 minus 5. 7x equals negative 14. Divide by 7. Divide by 7. X equals negative 2. Now we go here, plug in the negative 2 for x. And y equals positive 8 minus 5. Y equals 3. So that coordinate is negative 2, 3. My handwriting's so much better today. Here I'm going to solve for y. I will minus the 2x. Y equals, and now my handwriting is getting messy. Good, and I'll take this one. 3x. Now let's move this again. (3x plus 2). Instead of writing y, we're going to write negative 2x plus 1 equals 3. 3x minus 4x plus 2 equals 3. Negative x plus 2 equals 3. Minus 2, negative x equals 1. Let's multiply by negative 1 to isolate x. And now we're going to plug it in. Negative 2 times negative 1 plus 1. Y equals 2 plus 1. Y equals 3. So we get negative 1, 3. Good. I like that. I think that's good. And if we take these values, negative 1, that makes negative 2 plus 3 is 1. And that makes negative 3 plus 6. Negative 3 plus 6 is 3. So it checks if you plug it back in. I'm going to take the top equation and I'm going to solve for y, so I will subtract 3x. Y equals negative 3x plus 7. Take this, 2x minus 5, instead of writing y, negative 3x plus 7 equals negative 1. Distribute the negative 5. That makes positive 15x minus 35 equals negative 1. That's 17x minus 35 equals negative 1. Let's add 35. 17x, sorry. I knew that was going to do that. 17x equals 34. Divide by 17. X equals positive 2. Y equals negative 3 times positive 2 plus 7. Y equals negative 6 plus 7. Y equals 1. The coordinate is 2, 1. I'm going to solve for x. Keep it simple. Keep it simple. Don't make it any harder than it needs to be. So we'll add 3y to both sides. We get x equals 3y minus 5. And now we want to use the other equation, 2. Instead of doing x, we'll say 3y minus 5 minus 5y equals negative 9. Distribute that 2 is 6y minus 10 minus 5y equals negative 9. Combine like terms on the same side. That's y minus 10 equals negative 9. Add 10 to both sides. Y equals 1. Plug it back into the other equation. You can plug it into any of these, not this one. You can plug it into this one or the equivalent fraction to that. So don't feel like you have to. It's just conducive, right? If we're looking for x, this says x equals. So just plug that in. Keep it easy. 3 minus 5, x equals negative 2. So that coordinate is negative 2, 1. Looking at these equations, I see that this one's almost isolated. So I'm going to manipulate that. I'm going to use this equation. I'm going to write an equivalency. X equals 4y plus 3. And then we're going to take this top equation and we're going to plug that in. 4 instead of x. 4y plus 3 minus 2y equals 5. So 16y plus 12 minus 2y equals 5. That's going to be 14y plus 12 equals 5. Minus 12 gives us 14y equals negative 7. Almost forgot that negative. Divide by 14, and we get our first fraction, negative 1/2. Shouldn't change anything. It's still, still a value. It's still a value that is equivalent to it. So we go back to this, and we have 4 times negative 1/2 plus 3. We just got to be good with our fractions. That produces negative 2. Denominator cancels with the numerator. X equals 1. So that coordinate is 1, negative 1/2. We plug it back into the original. 4, what's that? We got 4 times 1 is 4. Negative 2 times negative 1/2 is 1. 4 plus 1 is 5. 1 is equal to negative 4. Negative 4 times negative 1/2 gives you positive 2. And 1 plus 2 is 3. So it still checks. I'm going to find this one's the easiest one to isolate. I'm going to isolate for y. Negative 2x. Y equals negative 2x plus 3. Then we take the bottom, 3x plus 2 times negative 2x plus 3 equals 5. 3x, let's distribute the 2. Negative 4x plus 6 equals 5. Negative x plus 6 equals 5. Minus 6. Negative x equals negative 1. Let's get rid of that negative coefficient. X equals 1. And let's now solve for y. Y equals negative 2 plus 3, or y equals 1. So that solution is 1, 1. Did I write the solution? Yes, I did. Ooh, all right, let's do this one. This is how I would isolate. This one is close. I would actually add x to both sides. I get 3y equals x minus 8, and then I'd add the 8 over. And we get 3y plus 8 equals x. And now I come back to this equation, plus 2, and I have x equals 3y plus 8 equals negative 6. So instead of moving the 3y and then multiplying everything by negative 1, it just opens for more sort of mistakes. So I made it simple in that way. 5y plus 6y plus 16 equals negative 6. That's 11y plus 16 equals negative 6. Let's minus 6 minus 16, excuse me. 11y equals negative 22. Divide by 11. Y equals negative 2. Now we can go back here. We still are looking for our x, so just because it's on the right side doesn't change anything. We can still do this. So we're going to substitute the negative 2 in for y, which allows me to simplify the left side and find out what my x value is. And I get the point 2, negative 2, x, y. So we're still going to make sure that our coordinates are in alphabetical order. This one's easy. Minus the 3x, minus the 3x. Y equals negative 3x plus 2. I'm always going to put it in standard form. 2x plus 3 instead of writing the y. Negative 3x plus 2 equals negative 8. Distribute the 3. That gives me negative 9x. That gives me plus 6 equals negative 8. Negative 7x plus 6 equals negative 8 minus 6. Negative 7x equals negative 14. Negative divided by negative is a positive 2. Then we take y equals 3 times 2 plus 2. Y equals negative 6 plus 2. Y equals negative 4. So 2 comma negative 4. These, you see how they are easy. And now we're just repeating. We haven't had any weird ones yet. It may come. Remember, the weird ones we saw when we were graphing was when you have the 3 types of things that can happen when you have systems. You can have one intersecting point, you can have parallel lines, and then you can have the same line. So we're looking for that situation. What does that look like? So I would assume that that's coming at some point. So we'll be aware and just know, hey, that's what it looks like. But we don't have that yet. Negative 4y plus 14 minus y equals 4. That's negative 5y plus 14 equals 4 minus 14 minus 14. Negative 5y equals negative 10. Divide by negative 5. Y equals 2. So we get x equals negative 2 times 2 plus 7. X equals negative 4 plus 7. X equals 3. So that solution is 3, 2. Making sure that my negatives were okay. We can check. If you get a little iffy, maybe you check. 3 times 3 plus 4 is 7. 6 minus 2 is 4. That worked. Oh, all right, this is nice. This one's already solved. So we're already isolated here. So I'm going to take this, and I'm going to plug it in for the x in the other equation above. So this is going to become, instead of writing x, I write negative y minus 6 minus 3y equals 2. That is negative 4y minus 6 equals 2. Add 6, add 6. Negative 4y equals 8. Divide by negative 4. Y equals negative 2. And now we have this already isolated, opposite of my y value. Tricky right there. Negative is here. My y value is negative 2 minus 6. So x equals 4 minus 6. X equals negative 2. And my solution is negative 2, negative 2. Okay, they tried to trick you by putting the variable on the other side. That doesn't fool me. I'm just going to take this and I'm going to plug it in for the y. So this equation becomes 5x plus 2 times my y value, which is x minus 5, equals 4. 5x plus 2x minus 10 equals 4. 7x minus 10 equals 4. Let's add 10 to both sides. 7x equals 14. Divide by 7, divide by 7. X equals 2. Let's take this equation. Y equals x minus 5. We say y equals 2 minus 5. Y equals negative 3. 2 comma negative 3. That wasn't harder. All right, I'm going to take this equation. Y minus 3 equals negative 2x. I'm going to add 3 to both sides. Y equals negative 2x plus 3. Let's take this and substitute it in for y, which is negative 2x plus 3 equals negative 20. Distribute the negative 2, which is positive 4x, minus 6 equals negative 20. 7x minus 6, we always simplify before we start moving. 26, did I make, let me see. Let's check, that's a weird, so this is, oh no, I'm sorry. Plus 6, sorry. I thought we were going to get negative 26. That's actually negative 14, that's an okay, reasonable. But if you get a funky answer, you might want to go back and check. So I thought I made a mistake. So y equals 7. We get negative 2, 7. It doesn't matter, both ones. I'm just going to take this because it's up top. And when we plug in for x, that's okay, that's not hard. So x plus 8 equals 2y minus 8 minus 8. X equals 2y minus 8. Not 4x, I'm plugging in for x. So it's going to be 4 times my x value, which is 2y minus 8 plus y equals 13. Distribute the 4. 8y minus 32 plus y equals 13. Let's combine like terms on the same side. We want to simplify the sides before isolating. Now we're going to add 32. 9y equals 45, which works out nice. Y equals 5. Come back to this equation. 2 times 5 minus 8. X equals 10 minus 8. X equals 2. 2 comma 5 would be my, whoa, okay. So the question is, do I want to substitute into the numerators, or do I want to deal with this and substitute back into a regular one? I'm going to take the harder of the two roads. So if we have u over 4 minus v over 2 equals 3, you know how we get rid of these variables? multiply by the common denominator. So I'm going to multiply everything by 4. Everything. This, and this. So that's going to cancel, and that leaves me with u. If I distribute that, the 2 in the denominator cancels with the 4 in the numerator. That leaves me with negative 2v equals 12. And now I'm going to add 2v, and I get u equals 2v plus 12. So I'm going to take that and plug it back into this equation. So let's move this one down. So instead of writing u, I'm going to write 2v plus 12 plus v equals 8. Let's distribute that 3. 6v plus 36 plus v equals 8. 7v plus 36 equals 8 minus 36. 7v equals negative 28. Divide by 7, divide by 7. V equals negative 4. And then we can come back to our u equation. U equals 2 times negative 4 plus 12. U, that's a horrible u. Mr. Mack has a hard time writing u's. U equals negative 8 plus 12. U equals 4. So we get uv 4 comma negative 4, alphabetical. U comes before v. Okay, I was wondering if they were going to get these questions. It's coming right over there. So we got 2 more, well, somewhat traditional. Let's keep it. This is already isolated, so we will take this value for x and we will plug it in to the x part in the equation above. So if we plug it in, we get 2. Instead of writing x, we write 2/3 y minus y equals 2. We're not afraid. Those 2's do not cancel. That 2 is in the numerator, 3 is in the denominator, doesn't cancel. So we get 4/3 y minus y equals 2. Let's write this in thirds. This is negative 1. So we'll write 4/3 y minus 3/3 y equals 2. Negative 1 is equivalent to negative 3/3. Now we have like denominators. We're going to combine their numerators. We get 1/3 y equals 2. Multiplied by the reciprocal. Y equals 6. Not too bad. Now we go back to this equation. X equals 2/3 times my y value, which is 6. 3 is in the denominator. 2 is in the numerator. 2 times 2 is 4. So we get 4 comma 6. Nice, clean, whole numbers. Same thing here. We're going to do the same exact thing. We'll take this value, plug it in to my x in the equation above. That is going to give us 5 times 3/5 y. This time it's going to cancel. Minus 4y equals negative 10. 5 in the denominator cancels with 5 in the numerator. Leaves us with 3y equals, or minus 4y equals negative 10. Negative y equals negative 10. Multiply both sides by negative 1. Y equals positive 10. Take that. 3/5 times 10. 5 in the denominator, cancel with 10 in the numerator, and we get 3 times 2 are in the numerator, so 6 comma 10. All right, this is what we've been waiting for. So when we isolate and plug it back in, notice what happens to the variables here. So these variables here are going to cancel. And then you're left with a statement that is false. If it's false, then it's no solution. If after substituting in, so you isolate, you substitute it back in, and this time if the variables cancel and you're left with a true statement, then it's going to be infinitely many solutions, or it's the same line. This is parallel lines. This is the same line because they lie on top of each other. So there will be an infinite number of solutions because that's where they intersect. So we'll see. Whoop, jump 2 problems. So let's see what it looks like. Well, this is nice. They at least set you up here. Now you're going to plug it in for y. So let's rewrite that equation. This is going to be x minus 3. Instead of writing y, we'll write 2x minus 1 equals negative 2. Let's distribute the 3. That's negative 6x plus 3. So this isn't even the type of problem. I did this right. Yes. Plugged it in for y. All right. So apparently it's not going to be the first one. That's negative 5x plus 3 equals negative 2 minus 3 minus 3. Negative 5x equals negative 5. The variables did not cancel. That's a horrible 5. So since the variables didn't cancel, we have a solution. It will intersect in a location. And then y equals 2 times 1 minus 1. Y equals 2 minus 1. Y equals 1. So the intersecting point is 1, 1. Okay, tricksters. Well, you don't have too many that it can happen. All right, so let's take this equation, x plus 2y equals 7. Let's subtract 2y. Remember, we want to, remember, we want to isolate for a variable and substitute. That's our initial motivation. So we have 2, instead of writing x, we write negative 2y plus 7 plus 4y equals 8. Distribute that 2, negative 4y plus 14 plus 4y equals 8. We're going to combine like terms. They cancel, and we get a false statement. So since it's false, that means it does not intersect in any place. So my answer is no solution. So these are parallel lines. If we had solved for them, solved for y, we would have seen that they had the same exact slope with different y-intercepts. Remember, they have to also not only have the same slope, but different y-intercepts mean that they're parallel to each other. So this is already isolated. We're going to plug it back into the y value here. So 2 times 2x minus 3 equals negative 3x plus 8. Distribute, that's 4x minus 6 equals negative 3x plus 8. We're going to add 3x. Let's try to keep our variables positive. We're going to move the constant to, I don't mind doing both at one time, 7x equals 14. Divide by 7. X equals 2. So we use this and we say y equals 2. Instead of x, we substitute the 2. Y equals 4 minus 3. Y equals 1. So the intersecting point is 2, 1. Whoa. So I'm going to deal with this. I'm going to get rid of that fraction. So I have x over 2 equals 3 minus y. I'm going to multiply everything by 2 to get rid of that fraction. This is writing an equivalent 6 minus 2y. I have x isolated. I'm going to go back to this equation, and I'm going to substitute 6 minus 2y plus 2y equals 6. They really tried to trick you. So common, like variables, those cancel, and you're left with 6 equals 6, which is a true statement. So the answer is infinitely many solutions. I like to say all points on the line. That just means they're the same line. This doesn't look fun either way. I'm going to get out of the way of, I'm going to deal with, early on, I'm going to deal with these fractions. I'll just do it here. So looking at the denominators, what's going to get rid of the denominators? 4 and 5. What's the common multiple? What's the least common multiple? 20. So I'm going to multiply everything times 20. And that's going to, 4 is going to cancel with the 20 and make 5x. The 20 times negative 2/5, 5 cancels with the 20 and make 4, times the negative 2y is negative 8y, and then we get negative 20. Now I'm going to move things around. I'm going to isolate. I'll isolate. None of these are going to be fun. I'm going to isolate for x. I'm going to add 8y. 5x equals 8y, and this is a real test of your manipulating equations and also dealing with substitution. When we divide, we're going to divide everything. So we get x equals 8/5 y minus 4. Now we're going to go back here. Let's go back to this color. And where we see an x, we're going to plug in 8/5 y minus 4 minus 5y equals 105. Okay. Nothing cancels. That's 72/5 y. I mean, maybe I made a mistake. I don't think so. Minus 36 minus 5y equals 105. Stick with it. 72/5 y. We're going to change that to fifths. That's negative 25/5 y minus 36 equals 105. 25 minus 72, that's 47 fifths. Y minus 36 equals 105. Add 36, add 36. 47 fifths y equals, that's 141. Multiply by the reciprocal, 45 over 5 over 47, 5 over 47, y equals, let's see if 141 divided by 47, hopefully it's a whole number, 3. So these cancel. Well, let's do this. So 47 goes into 47 once, 47 goes into 141 3 times. 3 times 5 is 15. So that's my y value. Was this the second to last problem? Aish. Okay, and now we go back to here and we're going to plug in 8/5 times 15 minus 4. 5 in the denominator, 15 in the numerator. Nope. We get x equals 8 times 3 is 24 minus 4. X equals 20. So we get 20 comma 15, a little bit bigger. That's good. Remember, you know what we can do also? We can take these and put them in Desmos, and it'll still show us that solution. So you can still use electronic devices. Let's go this. Let's do something crazy again. Let's do x over 3. Let's keep the fraction equals 2 plus y. Let's subtract 2 from both sides. We get x over 3 minus 2 equals y. We're going to take that and plug it into here. So 3x minus 9 times x over 3 minus 2 equals negative 4. 3x, let's distribute the 9. That's going to cancel to make negative 3x. That's going to make positive 18 equals negative 4. The x's cancel. You're left with the statement 18 equals negative 4. That's not true. That is false. So the answer is no solution for the last problem. All right. So lots of fun stuff. This is called the substitution method. We saw what some of the things that we are shooting to achieve in it. We want to isolate for one of the variables, then we want to substitute it into the other equation and simplify, and then replug it in to find the other value. Good luck.